This is a multicolor 3D print, made in one step. No painting, no multi-material, not even support. On paper, this technology should have killed FDM and SLA a long time ago, but it's dead. Before we get into the messy reality, let's rewind for a moment. Imagine it's around 2012. 3D printing is exploding. Everyone is talking about it, but most machines can only print one boring color. And then this shows up, the ProJet full color printer. The promise was huge. This machine could print in full color, photorealistic, straight out of the printer. No painting, no stickers, no assembly. Just load a file, press print, and get a completely finished model that looks exactly what it does on your screen. It could print incredibly detailed parts, complex shapes with internal cavities, multiple objects at once, and all without any support material. Compared to other industrial printers at the time, this felt almost like magic. Fast, clean, professional, and capable of things no FDM or resin printer could even dream of. The sales pitch was basically one machine, any geometry, any color, ready to use. This was the future of 3D printing. Why aren't these machines in every workshop today? So that's where the story gets interesting. So this is my machine, a relic from another time. And of course, it's broken. So I have to repair this machine because I need to print something. And I thought it's the perfect time to explain to you guys how this technology actually worked, but also why it kind of failed. Funny thing is that this technology actually was the reason for me to go into 3D printing, because I saw a video of it and I saw it producing three-dimensional parts in color, and that actually woke up my interest into 3D printing. So while I repair the machine, I can show you every detail on how this technology works, but also why nobody wants to work with it anymore, because this machine is maintenance nightmare. How this technology actually works is it uses a powder made out of gypsum. What I'm opening right now is the vacuum system, because you can suck unused powder directly back into the machine. But there is a little filter I need to clean once in a while. So here you have the powder. It's basically gypsum or plaster of Paris, just very fine porous powder. And this is the filter I need to just clean a little bit. So this powder reservoir is actually what provides the printer with its raw material for printing. It's fed through this funnel. You see it's filled up all the way to the top for a full print bed. And it's filled in here into a funnel. And down here you have a little dispenser. So it basically just slides open and lets some powder fall onto the print bed. So back here you can also see the reservoirs for the inks or the binders. We have cyan, magenta, yellow, and we also have black and a clear binder when it should stay white. They are of course filled from the front with cartridges, so you never have contact to them, because that stuff is nasty. That's why I wear my lab coat. If you get it into your clothes, it's stained forever. So let's go to the front. So up here in the front, you have your cartridges. The system is actually pretty cool. You buy those and you just plug them in, they empty out into the reservoirs, but those are expensive, around 120 bucks for about 0.3 liters. As soon as you drop the powder there, this slide actually has a little roller back here. And this roller grabs the powder and it just spreads it over the whole printing surface in about 0.1 millimeter thickness. It also has this carriage here. When I open it up, you see in here, you have ink cartridges. Those ink cartridges are just normal printer cartridges, but they're for plotters. So you actually have a hose system coming from the back. You see that here, all the colors coming in, and they get pumped into those little cartridges. Those little guys are one of the reasons why this technology actually failed. They're manufactured by HP, and HP actually stopped manufacturing them.
I don't like where this is going.
So the company 3D Systems just bought the rest of them on the market to basically make it possible to actually use these machines, but the prices of them gone through the roof. So you can buy them, like they used to cost like 50 bucks, And now they cost up to $300 per cartridge. And you use a lot of them because this is one of the biggest weaknesses of this technology. You use a printer technology that is very susceptible to dust, and you print in the dustiest environment you can imagine because you have this super fine powder everywhere. So those clog easy, they overheat easy.
So my machine actually had the issue that my cartridges overheated, even though I put in new cartridges right away. So I suspect that this is an electronics error. First things to do is, of course, to remove the powder that is in the bed. And that's actually one cool thing about that machine. You can suck it right back into the printer. And then I had to get to the so-called pogo card. And it's inside of this little carriage, and I can't tell you how often I already removed those screws and got to that pogo card on different machines, because that stuff breaks all the time and it's super expensive also. So it's not an easy feat to remove that and replace that. In the pogo card itself, you have those little pins that actually contact your printing cartridge, and those are spring loaded. The problem is that sometimes dust or like color like here gets into the little spring mechanism, and one or more of the pins actually like get stuck down, and also this little cable, it rips super easy. So you always have to check if maybe this is the signal wire that is broken. So first thing I did is I just thoroughly cleaned it using isopropyl alcohol, because maybe it's just a contact issue. And then I looked into the pins. You can see this one is stuck down. So what I normally do there, I soak it in IPA and try to get them loose. I succeeded in the end, and because I had a stuck pin, I actually just put it back into the machine, because most likely this was the issue at the end.
The color itself is a binding agent together with ink, and it's kind of like alive, so it's biologically active. So when it stands inside of those hoses, it can actually like change composition and kind of flock. And if those microscopic flocks get inside of your cartridges, it will actually clog them up and also get them to overheat. So what I always do, if it was like standing around a little bit, I suck some ink out of it and get it so it actually pumps fresh one from the tank. Most people don't have industrial 3D printers at home. That's why I'm excited to announce our partnership with one of the most competitively priced and high quality manufacturers out there, PCBWay. PCBWay is very renowned for their PCB manufacturing capabilities. They also offer industrial grade 3D printing, and with worldwide shipping, it will show up within days on your doorstep. It's black. This is also important, so there are no air bubbles. You see, there were air bubbles inside, and those air bubbles also travel inside your cartridge and get them to overheat.
So while I clean, I actually want to talk a little bit about my opinion why this technology died. I mean, you can see me on screen cleaning and cleaning and cleaning. So this machine is a super messy process, but it also has to be very, very clean for the cartridges to work. And as you can see, powder gets everywhere. Also, the powder, it gets stuck in places where it shouldn't get stuck, and the machine can actually not recover from it. So I think the process in of itself was just too big, too expensive, too messy to handle, and has too much manual labor involved in it to actually make an earning with it.
Okay, let's boot her up and see if that solved the problem. Okay. So it already happened. As you can see, our clear head overheated. So this means either my head is old and broken, even though it was a brand new one, but from the last time where the contacts weren't good, or something else is happening. So the only chance I have is take one of those very, very expensive new cartridges and put them in and start the whole process over again. So let's go for round 2.
Now it finally worked. So the printer prints a calibration pattern and then scans the color dot to just align the cartridges to each other and check on the color.
So while the machine is doing its calibration, we of course need something to print, and it should be full color, of course. So for this, I will use a new piece of software I just came across. The service is called Heatum 3D. It's one of those image to 3D model generator, but what I personally think is really amazing in this program is how clean the 3D models are. You know, most services like that, they produce awesome looking on the screen 3D models, but as soon as you remove the texture, it's actually all fuzzy and uneven. And if I just look at their examples they have, if you like just move your mouse over it, you can actually see the 3D models below, and the surfaces that should be smooth are smooth. So I think this program is even good if you want to produce something for FDM 3D printing. So I generated a picture using another AI, and I just drag and drop it into the window here. And I, of course, will use the newest model and the highest resolution to produce it. So I give it one picture of a very complex figurine, and let's see what it comes up with. So of course, this service is server-based. Otherwise, you would need a beast of a computer. So it takes some time. And because I use the highest fidelity and the highest detail and textures, it might take 20 to 40 minutes. Let's see how long it actually takes.
Sponsorship aside, I am so impressed how far AI actually come. Like, this kind of quality was unthinkable just a year ago. You have really clean and smooth surfaces. And what I am super impressed with is that it actually imagined the backside of my figurine, and it did all the little wrinkles and all the details of the beard and everything. Even the hand has the correct amount of fingers according to the picture. Also, the textures are actually great. It does not look like in the earlier days of AI where it was just smudge. It's actually high quality textures now. And I think the biggest upside is when you remove the texture, the whole figurine still looks great, and it actually does like very detailed surface texture. So even for SLA printing, that could be giving you a lot of detail to print out. I was wondering a little bit about the fingers in my gloves, that they looked a little odd, and I just thought it's the AI itself, but it was actually ChatGPT that messed up here and made fingernails on top of my gloves.
So after we finished repairing our machine, it's time to finally actually print. It's reliable when used correctly, or it should be reliable, and that's why they blocked you of doing anything. I can look at some reports. So that means if something breaks, you're just done for. It already started. Yeah.
Now I have to get all the parts out of the powder. You're seeing me be super delicate here. Those parts are fragile. That's why I use this little compressed air gun to actually remove the loose powder from my part. And when I say fragile, I mean really fragile. So I have to carefully lift it out and try to get as much powder of it before actually moving it, because the weight of the powder can already crush it. So after removal, there is a second step to actually make it stronger. But now it actually has kind of the mechanical properties of a cookie. And this is why, you know what? Let me just show you.
Now we get to the last and most messy step of this whole process. So our figurines are properly dried now, but they're still very fragile because they're just gypsum and some binder. If I can show you here, let's do it with my fingers. You see that? The color binder is only on the outside, and on the inside you just have a little bit of binder. So what we need to do is we now going to infiltrate it. And this is super messy because we're working here with the equivalent of super glue. I'm actually in this process going to double glove. If you even get a slight hole into this glove while you're working with it, you're basically glued to your glove. These chemicals are also very harsh. So you shouldn't breathe it in, and if you do, it really burns in your eyes and in your mouth. So of course, we take safety precautions. So I'm looking like I'm working with radioactive material just to infiltrate some figurines. And as you can see, if I put it over, the colors immediately pop. And this stuff now soaks into the part itself. I like the model, to be honest. So we have some where my face got purple because my yellow cartridge was blocked, and so the mix of the colors was not perfect. So we can't use them, so we would like to give them away to you guys. We have 2 of those. So to get one, simply comment "I want the figurine" down below and share the video, and you have to be subscribed, and then we will pick a winner that gets this shipped to them for free. Don't worry, we have special packaging to protect it. So what's the verdict on the technology itself? If the machine works, it's properly maintained and nothing is going wrong, it's actually great because you literally hit print, it just prints overnight, and it's actually really fast and can do a huge part. But there is the problem, if it works. So this machine is notoriously broken all the time, expensive to upkeep, expensive in all the material it uses up. So it's just a pain in the ass. And as you just saw, the post-processing is also quite messy and hard to do. This infiltration, working with like this glue-like substance, where I already, even though I have double gloves, I just glued my finger to my fingernail. So it's just messy and expensive and dusty and gluey, and yeah. I think this is one of the main reasons it died. But the main reason, in my opinion, is something we haven't talked about yet, and it's usability. The only thing you can do with parts printed there is look at it. Even though they pushed it in marketing as a usable part with even mechanical strengths, it's just not. It's still plaster. So the only thing where it's usable is figurines. Did this technology deserve to die? Full color printing is something we all want, but we want to have it usable. So we're very close with multi-material FDM right now, and this technology itself is just obsolete, I would say. But it was still a great technology as a foundation for new emerging technologies. For example, metal binder jetting. This technology is based on the technology of CJP and revolutionized metal manufacturing right now. So yes, I think it deserved to die, but I am glad it was here as long as it was. If you like this video and these technology deep dives, let me know what we should do next and maybe enjoy one of our next videos. Thank you for watching.